Hello and welcome to my channel. In this video we will solve 12th problem of 11th maths miscellaneous exercise on chapter 13. Okay, so the main question here is find the derivative of the following functions. It is to be understood that a, b, c, d, p, q, r and s are fixed non-zero constants and m and n are integers. Okay, so we have to find the derivative of the given function here. Here the given function is ax plus b the whole raised to n. Now before finding the derivative of this function, we will see the expansion of this expression. Okay, so we have ax plus b the whole raised to n. Now by binomial theorem, what you have here, you have to use the binomial theorem. So if we look at the binomial theorem, so it is like this: a plus b the whole raised to n is equal to NC0 a raised to n b raised to 0, then NC1 a raised to n minus 1 b raised to 1 plus NC2 a raised to n minus 2 b raised to 2 and so on, plus NC n minus 1 a raised to 1 b raised to n minus 1 plus NC n a raised to 0 b raised to n. Okay, so this is the binomial theorem. Now we have to use the binomial theorem for this expression. So what you will get, now your a here is nothing but ax, okay, and b is b here. So if you use the binomial theorem, you will get nc0 bracket ax bracket closed raised to 0, then here it is n, b raised to 0 plus nc1 ax raised to n minus 1 b raised to 1. Okay, then nc2 ax raised to n minus 2 b raised to 2 and so on. Then second last term will be ncn minus 1 ax raised to 1 b raised to n minus 1 plus ncn ax raised to 0 b raised to n. So this is what we have. Now let us continue. So we will get nc0 here, a x raised to n will be a raised to n x raised to n by law of exponents, a raised to n x raised to n. Then b raised to 0 is 1, so we'll get plus nc1 here, it will be a raised to n minus 1 x raised to n minus 1, and b raised to 1 is b, then plus nc2 a raised to n minus 2 x raised to n minus 2, b raised to 2 and so on. Then second last term will be ncn minus 1 a raised to 1 x raised to 1, that is ax, multiplied by b n raised to minus 1 plus ncn a x raised to 0 will be 1 and this is b raised to n. So b raised to n. Okay. Now what we have to do here is we have to write nc0 by using the formula. The formula here is ncr. ncr is nothing but combination, right? N combination r. So the formula you have studied, that is n factorial divided by r factorial n minus r factorial. So that we have to use it here. So we will get n factorial divided by 0 factorial n minus 0 factorial. Okay, a raised to n x raised to n plus here it will be n factorial divided by 1 factorial n minus 1 factorial a raised to n minus 1. Then we will write constants together. So a raised to n minus 1 multiplied by b x raised to n minus 1 plus nc2 will be n factorial divided by 2 factorial multiplied by n minus 2 factorial a n minus 2 b raised to 2 x raised to n minus 2. Okay, then plus um, this will be n factorial divided by n minus 1 then multiplied by n minus bracket n minus 1 factorial, right? We are just using the ncr formula. Then a multiplied by b raised to n minus 1 x plus ncn will be n factorial divided by n factorial multiplied by n minus n factorial b raised to n. Okay, so we will continue here. N factorial divided by 0 factorial is 1 and n minus 0 factorial will be n factorial a raised to n x raised to n plus n factorial divided by 1 factorial is 1, then this is n minus 1 factorial a raised to n minus 1 b x raised to n minus 1 plus this is n factorial divided by 2 factorial is 2 and this is n minus 2 factorial and then a n minus 2 a raised to n minus 2 b square x raised to n minus 2 plus n factorial divided by n minus 1 factorial multiplied by, so this will be what, n and minus n will get cancelled right here, n and minus n will get cancelled and minus of minus 1 is 1, so you will get 1 factorial. Okay, plus okay, we have to write this a b raised to n minus 1 x plus n factorial divided by n factorial n minus n is 0, so 0 factorial multiplied by b raised to n. Okay, so now if you can see here, n factorial and n factorial will get cancelled, so what will remain is a raised to n x raised to n. Then what we will do is we will write n factorial as n times n minus 1 factorial. Okay, so this you have studied in permutation and combination chapter. So n factorial we will write it as n multiplied by n minus 1 factorial divided by n minus 1 factorial a raised to n minus 1 b x raised to n minus 1 plus n factorial we will write it as n multiplied by n minus 1 multiplied by n minus 2 factorial. So n multiplied by n minus 1 multiplied by n minus 2 factorial divided by 2 times n minus 2 factorial. And then we have a raised to n minus 2 b raised to 2 x raised to n minus 2, then plus so on plus n factorial we will write it as n times n minus 1 factorial. Okay, so n times n minus 1 factorial, then divided by n minus 1 factorial a b raised to n minus 1 x a multiplied by b raised to n minus 1 x. Okay, then this n factorial will get cancelled, and what you'll get is b raised to n. Okay, so we will get a raised to n x raised to n, and then this n minus 1 factorial will get cancelled, and so we will get plus n times a raised to n minus 1 b x raised to n minus 1 plus n minus 2 factorial will get cancelled. We'll get n times n minus 1 divided by 2 a raised to n minus 2 b raised to 2 x raised to n minus 2. Okay, then plus this n minus 1 factorial will get cancelled. We'll get n a raised to bx minus 1 b raised to n minus 1 x plus b raised to n. So this is nothing but ax plus b raised to n. Okay, so what we have to calculate is the derivative of this, right? So to calculate the derivative of a raised to ax plus b raised to n, we will take d by dx ax plus b raised to n. So that means d by dx of this, what we have got here. So that is nothing but a raised to n x raised to n plus n times a n minus 1 b x raised to n minus 1, then plus n times n minus 1 divided by 2 a n minus 2 b raised to 2 x raised to n minus 2, and so on, plus n a b raised to n minus 1 x plus b raised to n. Okay, so what we'll get here? See, derivative of this whole thing will then become derivative of sum of derivative of each terms, right? So that derivative will go to each of this term. So we will get d by dx a raised to n x raised to n plus dy dx n a raised to n minus 1 b x raised to n minus 1 plus d by dx of n multiplied by n minus 1 divided by 2 a raised to n minus 2 b raised to 2 x raised to n minus 2 and so on, derivative of n a b raised to n minus 1 x plus derivative of b raised to n. Okay, now you know that whenever you have derivative of constant times a variable, the constant comes out of the derivative. Okay, so what we will get here is a raised to n derivative of x raised to n plus, now this is the constant here, n a raised to n minus 1 b, so that will be out of the derivative. So a n times a raised to n minus 1 b times derivative of x raised to n minus 1, then plus, now the constant here is n multiplied by n minus 1 divided by 2 a raised to n minus 2 b raised to 2, so that will come out of the derivative. So n times n minus 1 divided by 2 a raised to n minus 2 b raised to 2 derivative of x raised to n minus 2 and so on, plus, now this is the constant, so that will come out of the derivative n a b raised to n minus 1 derivative of x plus, this is a constant here, so that will come out of the derivative b raised to n derivative of 1. Okay, because whenever this constant will come out, there is no other term, so derivative of 1 will get here. So we will continue. So we will get a raised to n derivative of x raised to n will be what? So you have the formula here, right? Derivative of x raised to n is nothing but n times x raised to n minus 1. So that we will use. So we will get n times x raised to n minus 1 here. N times x raised to n minus 1. Okay. Plus n times a raised to n minus 1 b. N times a raised to n minus 1 b. And again the formula we have to use here. So derivative of x raised to n minus 1 is n minus 1 x raised to n minus 1 minus 1. That is n minus 1 times x raised to n minus 2. N minus 1 times x raised to n minus 2. Then third term is n times n minus 1 divided by 2. N times n minus 1 divided by 2. A raised to n minus 2 b raised to 2. And derivative of this x raised to n minus 2 will be n minus 2 times x raised to n minus 3 and so on. Now second last term will be n a b raised to n minus 1 and derivative of x is 1, right? This we have studied, plus b raised to n and derivative of 1, right? Derivative of 1, so derivative of constant, derivative of any constant is 0, so we will get 0 here. So we will get here a raised to n and x raised to n minus 1 plus n a. So what we will do here is we will write this besides n. So n times n minus 1 a raised to n minus 1 b x raised to n minus 2, then plus n times n minus 1 right here, and we will write n minus 2 besides n times n minus 1. So n minus 2 divided by 2 is there here, then a raised to n minus 2 b square x raised to n minus 3 plus n a times b raised to n minus 1 plus b raised to n times 0 is 0. Okay, so what we will get here, see, in the next step we have to take n common. You can see that n is common for each term here. This is 0, right? So this we don't need to write here. So n we can take common. So n, if we take common, n times a raised to n x raised to n minus 1. And one more thing we will do, we will take a common here, okay, along with n. So then what we'll get here, since you have taken one a out of each of the term, the first term will become a raised to n minus 1 x raised to n minus 1, because a we have taken out from a raised to n. So by law of exponents we'll get a raised to n minus 1, then plus, since n we have taken common, n minus 1 we will get, then here we will get a raised to n minus 2 because a also we have taken common, b will be b here, x raised to n minus 2 plus, here we will get n minus 1 times n minus 2 divided by 2, and a raised to n minus 3 b raised to 2 x raised to n minus 3, okay, plus, and so on. Here we will get b raised to n minus 1, okay. Now let us continue. So n a multiplied by, now if you look at this here, uh, 1 is multiplied here, right? Now if you look at the combination n minus 1 c n minus 1, so if you look at the combination n minus 1 c n minus 1, what we will get, we will get n minus 1 factorial divided by n minus 1 factorial, and multiplied by n minus 1 factorial, n minus 1 minus n minus 1 factorial. Okay, instead of looking at n minus 1 c n minus 1, we will look at n minus c 0. So we will get what, n minus 1 divided by 0 factorial, 0 factorial, then multiplied by n minus 1 minus 0 factorial. Okay, so we will get n minus 1 c0 equal to n minus 1 factorial divided by 0 factorial is 1, and multiplied by n minus 1 minus 0 will be n minus 1 factorial. So n minus 1 factorial, and this is nothing but if you cancel the numerator and denominator we will get 1. Okay, so instead of writing 1 here, what we will write is n minus 1 c0. Okay, so n minus 1 c0, and we have a raised to n minus 1 x raised to n minus 1 plus, now if you look at n minus 1 and if you look at the combination n minus 1 c1, we will get what? N minus 1 factorial divided by 1 factorial times n minus 1 minus 1 factorial. So that is nothing but n minus 1 factorial divided by 1 factorial is 1, and here we will get n minus 2 factorial, right? Now suppose we use the formula in the combination chapter here. So n minus 1 factorial we can write as n minus 1 times n minus 2 factorial divided by n minus 2 factorial. So if you cancel n minus 2 factorial from numerator and denominator, we will get n minus 1. Okay. So instead of writing n minus 1 here, we will write n minus 1 c1. Okay. Minus 1 c1, and then we have what? A raised to here a raised to n minus 2 b x raised to n minus 2. So a raised to n minus 2 b x raised to n minus 2. So similarly, this will become n minus 1 c2 by using this formula. Okay, so n minus 1 c2, and then what we have here is a raised to n minus 3 b raised to 2, a raised to n minus 3 b raised to 2, x raised to n minus 3. Okay, and so on. The last term will be here. You have 1. So instead of writing 1, we will write n minus 1 c n minus 1. And we have b raised to n minus 1. So we will get n times a, n minus 1 c0, and then what we'll do is we'll combine this by law of exponents. So ax raised to n minus 1, and instead of 1 here, we will write b raised to 0, then plus n minus 1 c1. So a raised to n minus 2 x raised to n minus 2 we can write as a raised to x raised to n minus 2 times b plus n minus 1 c2. Instead of writing a raised to n minus 3 x raised to n minus 3, we will write ax raised to n minus 3 b raised to 2. Okay, and then plus here we will write yeah, this is same, n minus 1 c n minus 1, and instead of writing 1 here, we will write a raised to x raised to 0 times b raised to n minus 1. Okay, so we will get na. Now if you look at the terms inside the square bracket carefully, this is nothing but the binomial theorem. For which expansion? So the expansion here is ax plus b the whole raised to n minus 1. Okay, so this is nothing but na ax plus b the whole raised to n minus 1. So this is the answer. Okay, derivative we have found out. So derivative of this, we started it here, right? And we got the derivative as this, na ax plus b raised to n minus 1. So that's it in the video. We will meet in the next video.